Now, what is the difference between the BFS and the DFS? Again, when we talk about in form of a GH, then BFS is work used to find the shortest path only, which use the distance as a heuristic. So what it uses a distance as a heuristic, and the distance between the starting node and the goal node is taken as a heuristic. BFS mainly किस पे work करता है? It works on finding the shortest distance between a search and the destination, or the source and the destination. Or simply we are talking about BFS is a searching algorithm used to find the shortest path which use a distance as a heuristic. And the distance between the starting node and the goal node is taken as a heuristic, and it defines the evaluation function for each node n in the graph as f equal to hn, where h is the heuristic function, and the heuristic function will be work on the heuristic value. And what is the A asterisk we have talked about? We have talked about A asterisk is a searching algorithm which is used to find the shortest path, which calculate the cost of all its neighboring nodes and select the minimum cost node, right? And it defines the evaluation function based on a fn equal to gn plus hn, where hn is the heuristic function and gn is the past knowledge acquired while searching. So here it works on the past knowledge also. So what is the difference between a asterisk and the BFS? They both work on the evaluation function, and they both define the evaluation function for each node or the number of nodes n of the graph, and the both have a evaluation function which is denoted by a fn, and this evaluation function determines which node to be expanded first while searching, and both search algorithms mainly differ in their evaluation function only. Where fn is the evaluation function, gn is the past knowledge required, and while hn is the heuristic function only. So when we talked about in terms of an evaluation function, so evaluation function of a BFS is just fn equal to hn, and h is here the heuristic function here. And when we talked about the A asterisk search, the evaluation function of a asterisk search is fn equal to hn plus gn. Now, what is the past knowledge? What comes under the past knowledge? So this algorithm does not involve any past knowledge because it does not involve gn here or the cost here. But the A asterisk function involves the past knowledge. As we have seen in the disadvantage of a BFS, that BFS is not always complete, but A asterisk will be complete. So here BFS is not complete in terms of a completeness. BFS is not complete, but A asterisk is always complete, or is complete as compared to BFS. Another parameter when we talked about the optimal solution, right? And the best difference is the time and the space complexity that we will talk about. So here the optimal, the BFS is not optimal as the path found may not be the optimal. A asterisk is the optimal as the path found is always optimal. And when we compare it with the hill climbing also, the hill climbing is, as we are talking about the BFS, the path is not optimal as the path which has been found may not be optimal, but the A asterisk is optimal as the path always optimal here. Then in terms of our time and the space complexity, BFS is time complexity based on b to power m, and the space can be polynomial. And when we are talking about asterisk, it times complexity is also b to power n, and the space complexity is also b to power m, where b stands for here the branching and m stands for the maximum depth of the search tree. So when we are talking about in terms of a time complexity, both have a same kind of a time complexity, but there is a difference between a space complexity. What we understand by the polynomial, or what do you understand by the space complexity? Can anyone explain? Yes, any one of you?
A space requires any algorithm for execution.
Okay, space. Then what is a memory in terms of a memory? It requires a less memory. What requires the less memory? The BFS requires the less memory because it doesn't require a memory for the past functions also, right? Or the past knowledge. But when we are talking about the asterisk, it requires a more memory for the past knowledge also. Kept, it keeps all the fringe or the border nodes in a memory while searching, and it keeps all the nodes in a memory while searching. So here it is not dependent on the history, and it is not as the BFS. Here we are talking about that the BFS is not depending on the past knowledge, so that's why it requires a less memory, and asterisk is required a more memory. Why? Because of a past nodes also, because it only kept the fringe or the border nodes that are in a present state, but the asterisk keeps all nodes in a memory while searching. So that's why it requires a more memory. Now, what we are saying that if the space complexity is a polynomially bound or the algorithm is said to be executable in a polynomial space, what do you understand by that? Most of the problems or the many problems for which the non-polynomial time algorithm has been found, which can be solved based on a space or the amount of a space bounded by a polynomial in the length of the input. What kind of an input we are talking about here? What is a polynomial space? We are saying a space which is basically the equidistance translates like we are which is having the equidistance from a particular node only. So here it depends on the polynomial function. So here we have talked about the three algorithms, and the unit one consists of the other algorithms is we have talked about the blind search strategies in which the uninformed search techniques, we have talked about the BFS, DFS, and then the heuristic search techniques, we have talked about the hill climbing, BFS and the asterisk, and now we will talk about the minimax search procedure for the game playing and the A0 asterisk algorithm. So we will discuss the new algorithm tomorrow, and tomorrow we will complete this unit.